This is topic 14.4, homeostasis. These are your objectives. The first thing we've got to look at is defining homeostasis. Now, it's basically keeping everything similar, maintaining a constant internal environment, whether that's CO2 concentration, oxygen concentration, temperature of the blood, whatever it is, tissue fluid, it's got to be kept constant, because if not, enzyme activity can be affected, chemical reactions can therefore be affected, respiration levels and such. The next thing we've got to do is explain a thing called negative feedback and how homeostasis works. Homoiotherms and poikilotherims are two different types of organisms, basically warm-blooded or cold-blooded, as it says here. Now, your warm-blooded animals, they use a process called homeostasis to regulate their body temperature, and we'll talk about that later. But because of that, we mammals, birds, we need to ingest food to maintain the body temperature, because when we ingest food, we absorb chemicals and we can break them down to make energy during respiration. That energy can be used to keep the body warm. Cold-blooded animals, however, they regulate their body by staying in either the shade or sun, as reptiles would. The only problem with that is if body temperature falls due to cold environments, chemical reactions like respiration can become very slow or at a low rate, and therefore the energy produced is low, and if a predator does come along, then they're going to struggle to get away. Now, the term negative feedback, we're going to look at this in terms of the thermoregulatory centre, but it's not just involved in that, it's involved in many different things. Now, the TRC, the thermoregulatory centre, is in the hypothalamus of homoiotherms. Basically, it monitors the blood temperature and receives impulses from temperature receptors in the skin. As we talked about earlier in the topic, sensory receptors in the skin will send information to down along here to the brain. Now, we're talking about hypothalamus of the brain and the TRC inside that. Now, that will take information from the skin receptors, but also from the blood. It will then send messages down motor neurons to different areas of the body. One thing it does is cause vasoconstriction or vasodilation, depending on the temperature. Remembering that if it's too cold, a vasoconstriction occurs. If it's too hot, then vasodilation occurs to get rid of excess heat or to conserve the heat inside the body. Now, negative feedback basically just means that the messages going back to the brain will counter out the effects, the original messages that were going to the, say, blood vessels in this example of vasoconstriction and vasodilation. And as such, basically what it means is, as messages are sent from skin receptors to the brain saying, let's say for example, the body temperature is too hot, the brain will send messages therefore back to the skin receptors saying, right, you need to vasodilate the blood vessels. So vasodilation occurs and heat is lost through the skin by evaporation. Now, as vasodilation occurs, of course, body heat is being lost, the temperature of the blood will decrease, and skin receptors will detect that decrease in temperature. Therefore, the messages going back to the brain now are actually inhibiting the original messages coming down saying we need to vasodilate. The messages going back are saying actually the temperature's low now, so the brain will send new messages saying let's stop the vasodilation, we don't need to now, let's vasoconstrict because the body temperature's actually got a bit lower. So negative feedback is basically about sending a response back to wherever it came from that inhibits the original action that was brought about. And this is portrayed quite well here. As you can see, there's number one, there's a decrease in blood and or skin temperature. Therefore, it's sensed by the hypothalamus, whether that's by nervous impulses or measuring the blood. Then, because of that decrease in temperature, it causes vasoconstriction and muscle contraction, shivering. Because of these two things, these two responses, your body temperature will slightly increase. muscles because they'll generate heat, and the vasoconstriction causes less heat to be lost. Body temperature increases, therefore inhibiting the actions such as vasoconstriction and skeletal muscle shivering, because the information it's actually sending back to the hypothalamus now is saying that actually you don't need to do these two things now. Body temperature has risen. So inhibiting the actions that were first put about by the brain. This image just shows you the difference between positive feedback and negative feedback. Obviously, if your account balance grows, you get more interest. And if you get more interest, your account balance grows, and it just keeps getting bigger and bigger. That's positive feedback. That's causing positive response to the original action. Negative feedback, again, is just where the body temperature would rise, you'd sweat, and then because you sweat, the body temperature drops. It's negative feedback. The response here of sweating has caused the original action of sweating to be inhibited because of the outcome of body temperature dropping. Next thing you've got to do is describe the control of blood glucose concentration. Now, next thing you've got to do is describe the control of blood glucose concentration. Now, blood glucose shouldn't be an unfamiliar term to you guys right now. We'll start with after a meal. If you have a meal that's got large carbohydrate value, you're going to have a lot of blood sugar. A lot of blood glucose concentration is going to be high. If so, that's obviously quite dangerous. You don't want blood glucose levels to be high. So there's some cells called islets, which are in the pancreas, secrete insulin. Now, insulin is a protein, a chemical, which causes liver cells to take up glucose and store them as glycogen, thus reducing the amount of glucose in the blood. Vice versa, if the blood glucose levels falls, let's say after exercise, the islets secrete the opposing chemical glucagon, which causes liver cells to convert glycogen into glucose and be released into the blood, thus increasing the blood glucose back to normal levels. So they work in opposing ways. Insulin also helps convert carbs to fats. This is helpful because, again, if you've got too much glucose in the body, it's better to convert some into something else. It also helps stop turning protein into carbs because, again, if you've got a lot of carbs in the blood, glucose, you don't want more glucose being produced. And it also stimulates your cells to take up glucose for respiration. It shows how they work in opposing ways. So obviously you've got glucose, which is in the blood, and then glycogen, which is in the liver. It allows glucose to be converted into glycogen. Glucagon does the opposite. And insulin works if the blood glucose is too high, and glucagon works in the opposing way. Now, I'm not going to go into too much detail here. Blood glucose levels basically states what happens if you're at each of these different levels. If they're too low, you can go into a coma. This level is about normal. If your blood glucose levels are too high, then the kidneys will actually excrete the excess glucose. Now, this extra glucose could be due to your insulin or the function of insulin not being correct. Now, this could be due to a thing called diabetes. Diabetes is where the production of insulin or the function of it is affected, and as such, you won't be able to store glucose in the liver. In more detail now, type 1 diabetes is called insulin-dependent diabetes. Now, it's the less common of the two forms, and it's due to a failure of the islets to produce insulin. Therefore, blood glucose can't be regulated and can get too high or low. So basically, insulin is injected to overcome this. And it basically, after a meal, you'll have high carbohydrate levels, high glucose blood concentration levels, so you'd inject insulin. You also have to monitor your diet to make sure that you're not eating too much carbohydrate and carbohydrate heavy meals, and also you need to exercise frequently to burn off excess carbohydrates that may build up. Symptoms of type 1 diabetes due to not having enough insulin are things like being tired because cells aren't readily taking up glucose because insulin is not there to allow it to do that. It says here that insulin helps stimulate cells to take up glucose. So if insulin's not there, you will feel tired. Weight loss will occur because protein and fat can be converted into glucose, and you'll be urinating frequently because you'll have too much glucose in your blood and therefore be excreting it. You also need to monitor your diet, because if you have a high glucose meal, then you're going to have a lot of glucose in your body, and if you can't produce insulin, then you're going to have obviously the symptoms of having too much blood glucose concentration. Exercise needs to be frequent to burn off excess amounts of glucose. Objective G is to describe the maintenance of a constant internal body temperature regarding insulating, sweating and shivering. Now, the skin is basically a structure, and these are the different parts of it. Okay, so the basal layer is just here, and this creates new cells all the time and pushes older cells to the surface where they die and they're shed. The shed rate is pretty much equal to the production rate. The epidermis is the basal layer here and the cells above it, and the thickness of this layer is different in different areas of the body. The dermis, this layer here, has lots of different things in it, such as sebaceous glands, which can release secretions. You've got hair follicles, blood vessels, sweat ducts, and nerve endings. Under that is adipose tissue, and that's just underneath the dermis. One more thing to mention is that there are pigment cells in the epidermis that produce a substance called melanin. Now this substance is a black pigment, and the more of it you have, the darker your skin pigment will be. Now the function of the skin is, it has a few functions. First of all, protection. The outermost layer is dead cells, and it protects bacteria from getting in. So it's a barrier against bacteria. It stops the loss of water, and the melanin provides protection from UV rays. So the skin's got quite a few functions. This is just an image, a longitudinal image of a section through the epidermis and dermis of the skin, just because you might have to identify certain parts. This stuff you should know already. This outlines that there are some sense receptors in the skin, such as sensing heat, cold, pain, touch and pressure. Receptors, you should already know what they do, and temperature regulation, we have already discussed vasodilation and vasoconstriction. Just regarding temperature control, a couple of extra things. Normal body temperature is 37, but above or below that value can be dangerous. Hands and feet have different temperatures, like if you're that person that has cold feet or cold hands, that might be because you have bad circulation, but core temperature is always usually constant. It's around 37 because that's the best temperature for enzymes to function. Now, core temp can be measured using a thermometer under the tongue, and the brain also detects this in the TRC of the body, of the brain, in the hypothalamus. And again, we've discussed this stuff already. Heat loss and gain, again, we've talked about, but it occurs from the surface of the body. Now, this can be by conduction, convection, evaporation, and radiation. You will have talked about these in physics, maybe. We don't need to go into too much detail about these. Adipose tissue is fat, and it's an insulator. Hence, whales have thick blubber, so do polar bears to keep warm. Now, adipose tissue is made of fat and water, but the more fat in adipose tissue, the better, because it's a better insulator. Heat gain is generally internally from respiration, but you can also get it from the surroundings if you're in a really hot place. The last thing I'm going to talk about today is overheating and overcooling. Now, you know that vasodilation occurs if the body temperature is too hot, and that can be paired with sweating to get rid of latent heat. Now it basically works like this. From a sweat gland you will release sweat on top of the epidermis of the skin. Now during vasodilation the blood will flow towards the epidermis of the skin, and heat will be conducted through the skin towards the surroundings of the body. The sweat will easily absorb this heat from the body or the blood, and as it evaporates, i.e. changing state from liquid to gas, latent heat will be lost. Latent heat is simply described as heat absorbed or released as something changes state. So as the sweat, as a liquid, changes state to a gas, it takes latent heat from the body. Overcooling is where you'll have less blood flowing to the skin, so less heat is dissipated to the surroundings, sweating stops, and shivering occurs, which is automatic bursts of rapid muscular contraction. Basically your muscles contract, you can't really control it, and due to respiration this creates energy which can be released as heat, and as such make